Hey everyone, I hope you're ready to tackle some properties today. That is properties of numbers, lesson 1-3, page 16 in your algebra book, if you want to follow along. Today I just took pictures of the book because there was going to be a lot to type out and it's kind of hard and cumbersome on an iPad. So I just took a picture of the book and we're just going to go over and discuss it. Hopefully it won't take all that long. So let's just jump right in. At the top of the page, it says the expressions 4k plus 8k and 12k are called equivalent expressions because they represent the same number. The properties below allow you to write an equivalent expression for a given expression. All right, let's just go property by property. We won't spend too much time on it, but we need to go through it nonetheless. The reflexive property, any quantity is equal to itself. For any number A equals A. So just substitute over here. They give you the example. They substituted 5 for A, so they get 5 equals 5. That's kind of a duh statement. And then down below, 4 plus 7 equals 4 plus 7. If you wanted to check that, you could, which would just be 11 equals 11. The symmetric property, if one quantity equals a second quantity, then the second quantity equals the first. So if A equals B, then B equals A. What they did over here in the example, they said 8 equals 2 plus 6, and then they just flipped it around, or the symmetric property, switched it around, and then you get 2 plus 6 equals 8. The transitive property, we're just knocking them out. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. So then over here, for the symbols, they have if A equals B and B equals C, then A also equals C. Over here, it's a little bit longer. If 6 plus 9 equals 3 plus 12, which it does, they're both 15, and 3 plus 12 equals 15, which is right, then 6 plus 9 equals 15. So here's my A, this is my B, this is my C, the 15. Here they say A is equal to B, B is equal to C, so that means my A, which is also up here, is equal to my C. And the very last one, at least in this table, is a quantity may be substituted for its equal in any expression, which is known as the substitution property. If A equals B, then A may be replaced by B in any expression. So if n were to equal 11, then I can go ahead when I have 4n equals 4 times 11 when I plug in 11 for n. Alright, those are the few properties that we're going to need to know. The additive property is pretty simple one to know. Any number plus 0 is that number. 2 plus 0 is 2. Okay, any number. 500 billion plus 0 is 500 billion. That's the additive property. The additive inverse property is a number and its opposite are additive inverses of each other, and that will always equal 0. So 3 plus the opposite of 3, which is a negative 3, is 0. So 500 billion plus a negative 500 billion is 0, always. Moving on, we have the multiplicative property and the multiplicative property of 0 to talk about on this page, as well as multiplicative, I don't know what it is about that word, inverses, or the reciprocals. Alright, the multiplicative identity is any number times 1 is that number. So over here, 14 times 1 is 14, or 1 times 14 is 14. That's the same as if it was 500 billion times 1 is 500 billion, or 1 times 500 billion is 500 billion. The multiplicative property of 0 states that any number multiplied by 0 is 0. Here the example is 9 times 0 equals 0, and 0 times 9 equals 0. So, same thing, 500 billion times 0 is always going to be 0. And 0 times 500 billion is always going to be 0. Not too hard. Multiplicative inverses Okay, if you think of every number A, B, where A, this is just, I'm not going to read that. That's just going to be, just know that A and B stand for different integers, different numbers. And all they're going to say is A over B times B over A is always going to equal 1. So over here in the example, they have 4/5 times 5/4. They multiply by the reciprocal is always going to be 1. So if you wanted to try that out and you had 3/4 times 4/3, that's going to be 1 because those two are inverses of each other. Last two for the day is the commutative property for addition and the associative property. The commutative property says that we can add in any order. So we can do 2 plus 4, or we can do 4 plus 2. It doesn't matter. It's going to be the same result. They'll both give me 6. You can also do it for multiplication. 7 times 11 will give you 77, and 11 times 7 will give you 77. Okay, this property only works for addition and multiplication. This will not work for division or subtraction. You'll get a completely different answer if you try to use a commutative property with either subtraction or division. The associative property is the way that you group 3 or more numbers when adding or multiplying. It does not change the sum or the product. So down here, this is a really grainy photo, and I'm not sure why it turned out to be grainy. It didn't look grainy, so I apologize for that. But this example is in your book. If you want to look at your book, it's page 18. We have 3 plus 5 plus 7 equals 3 plus 5 plus 7. And if you notice there on the left side, the parentheses are between the 3 and the 5. And on the right side, the parentheses are surrounding the 5 plus the 7. So if we used our order of operations in order to check if we would get the same answer, we would get 3 plus 5, parentheses first, is 8, plus 7, which would be 15 on the left side. Over on the right side, the parentheses tell us to do 7 plus 5, which would be 12, and then plus 3, which would be 15. So we get 15 equals 15. So in fact, we can group our symbols or add our numbers in any order that we want to, as long as we're using addition or multiplication. Again, this will not work with subtraction, or division. All right, that's all I really wanted to cover for today. Nothing too earth-shattering. Pretty much the same as we did last lesson, except that we're adding properties that allow us to explain why we're able to perform certain operations. Your homework will have you evaluate expressions, and then they just want you to tell what property you use that allows you to do that. Hope this helps. Hope you understand it a little bit better. Peace out.